Hello everyone, welcome to the video on basics of mathematics part 2. So in the part 1 video we had discussed about the remainder theorem and I discussed 3 identities in mathematics. So today we will discuss some more identities and we will also cover laws of indices, ratio and proportion, and we will talk a little bit about number systems. So in the previous video, we had discussed 3 identities, namely that of a cube plus b cube, a cube minus b cube, and a plus b plus c whole square. Now today, this is the 4th identity, which is very important identity. So the identity is that of the expression a cube plus b cube plus c cube minus 3abc. So rather than just telling you the answer of this identity, I will solve this identity in front of you, as it is very important identity, and I highly recommend you to remember the 2 forms which I will show you by solving this expression in front of you. So now let us see. In this expression we can see a cube plus b cube. So we can apply the formula which we learned in the previous video. So by this we will get, so on applying a cube plus b cube formula, we will get a plus b whole cube minus 3ab into a plus b. Now the remaining terms we will write it as it is, plus c cube minus 3abc. Now we can see 2 cubic terms, so we will again apply a cube plus b cube formula on this 2. So here a becomes a plus b and b becomes c. So a plus b whole cube, a plus b plus c whole cube minus 3ab, that is a plus b into c. 3ab into a plus b. So here a plus b is a plus b plus c. And these 2 terms will write it as it is, minus 3ab into a plus b minus 3abc. Now we can see that here 3ab is common in both these 2 terms, so we will take it common. So we get a plus b plus c whole cube minus 3 into a plus b into c into a plus b plus c minus 3ab common and a plus b plus c. Now from all these 3 terms we can take a plus b plus c common. So we'll get a plus b plus c into a plus b plus c square minus 3 into a plus b into c minus 3ab. Now we have already seen the identity for this expression, which is a square plus b square plus c square plus 2 into ab plus bc plus ca. So we apply this formula, a plus b plus c into, we expand this, a square plus b square plus c square plus 2ab plus 2bc plus 2ca, and by opening these brackets we get minus 3ac minus 3bc. So minus 3ac minus 3bc and the remaining term minus 3ab. Now we can see here this 2ab minus 3ab is minus ab, 2bc minus 3bc is minus bc, and 2ca minus 3ac is minus ac. So we can write it as a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So this is the first form of the fourth identity which you need to remember. So I'm just writing remember. By remember I mean that it is highly recommended to remember this form. And the other form of this expression is a plus b plus c into a minus b whole square plus b minus c whole square plus c minus a whole square whole divided by 2. So these are the two forms of the identity 4. So the second form, I leave it to you as an exercise to verify. See, what you have to do is open these brackets by applying the a minus b square identity, which I think everybody must be knowing, that is a square minus 2ab plus b square, and then divide the whole expression by 2. You will get the first form, and hence the both forms are same. So it is highly recommended for you to remember both these two forms. Now we come to laws of indices. So I will cover the basic laws of indices, which I think so everyone must be knowing. So it will be just a recap for you. First law is a to the power m plus n is equal to a to the power m into a to the power n. The second law is a to the power minus m is equal to 1 upon a to the power m. The third law is a to the power 0 is equal to 1. Now here, keep in mind that a should not be equal to 0, or else it will become 0 to the power 0, which is an indeterminate form, and we will cover independent form later on. So just keep in mind a should not be 0. And fourth law is a to the power m minus n is equal to a to the power m upon a to the power n. So this fourth, as you can see, it can be derived with the help of 1 and 2. So we can apply first rule and say this as a to the power m into a to the power minus n, and then a to the power minus n can be written as 1 upon a to the power n by using the second rule. Now fifth identity is a to the power m whole to the power n is equal to a to the power m into n. So these were the laws of indices, and you should keep them in mind. Now we come to ratio and proportion. So in ratio and proportion, first let us discuss componendo, dividendo and componendo dividendo. So assume that if A by B is equal to C by D, so this is given, A by B is equal to C by D. Now if we add, now we know that if we add 1 on both the side of equality, then the equality still hold. So on adding 1 on both these sides, we get A plus B upon B is equal to C plus D upon D. So this is nothing but componendo. Now similarly, if we subtract 1 from both the sides of this inequality, that is A by B is equal to C by D, then we will get A minus B upon B is equal to C minus D upon D, and this is nothing but dividendo. Now so consider this expression number 1 and this 2. So on dividing 1 by 2, we get A plus B upon A minus B is equal to C plus D upon C minus D, which is nothing but componendo dividendo. I'm just writing in short. So this was about componendo dividendo. So now we see a few problems on ratio and proportion. So the question is that prove that, so this is basically given, if A by B is equal to C by D, then we have to prove that that is also equal to A plus C upon B plus D. So for this, what we will do, so take the given part, which is A by B is equal to C by D. Let me just write it down, whatever is given. So basically A by B is equal to C by D is given, and we need to prove that A plus C upon B plus D is also equal to A by B equal to C by D. So now we will take the given part and assume it to be K. So by this we get A is equal to BK and C is equal to DK. Now putting these values in A plus C upon B plus D, we get A plus C upon B plus D, that will be BK plus DK upon B plus D. So here I have put the values of A and C as A is equal to BK, C is equal to DK. Now taking B common from numerator, by taking K common in the numerator, we get K into B plus D upon B plus D. So it comes out to be K. So hence we have proved A by B is equal to C by D is equal to K, and which is also equal to A plus C upon B plus D. So hence prove. Now similar question on ratio and proportion is as follows. So the question is, given that a by b is equal to c by d, we have to prove that the ratio, that is a by b equal to c by d, is also equal to under root of a square plus c square upon under root of b square plus d square. So I suggest you to stop the video, to pause the video for about 2 minutes and try to solve this question. Don't take more than 2 minutes. And after solving, come back to the solution. Okay. So we will take the given part, a by b is equal to c by d, and assume it to be k again. So from this we get a is equal to bk and c is equal to dk from this. Now putting the values in this expression, we get the root of under root of a square plus c square upon under root of b square plus d square. Now putting the values a is equal to bk and c is equal to dk in this, we get under root of b square k square plus d square k square upon under root of b square plus d square. Now we will take k common inside the root, k square common inside the root. So here we can take k square out of the root, which will become k, that is under root of k square is equal to k. And the remaining term will be under root of b square plus d square. So the numerator, this can cancel out by denominator, and that comes out to be k. Hence we have proved, So we assume that a by b is equal to c by d was given, and we assume it to be k, and this expression came out to be k by using the findings from this thing. So hence we have proved. Now next question is a very important question. So the question is evaluate. So you have to evaluate the following expression. So I will just write down the expression. After that, pause the video and try to solve this question within 3 minutes. Okay? And then come back to it. So you have to evaluate this expression. Let me read out it for you. So 1 upon 1 plus x to the power m minus n plus x to the power m minus p plus 1 upon 1 plus x to the power n minus m plus x to the power n minus p plus 1 upon 1 plus x to the power p minus m plus x to the power p minus n. So pause the video and try to solve this question in 3 minutes. Okay, so let us solve this. So now you can see that the denominator on all these three terms is not the same. So hence I cannot add the numerator by taking so I cannot directly add the numerator. I will have to take LCM, but that will become a very calculative and long solution. So what I will do is try to make the denominator same by using some laws of indices. So as you can see that in the first term, x to the power, here there is x to the power m and here there is x to the power m. So basically m is common, and in the second term n is common. Similarly in the third term p is common. So what will I do is multiply the numerator and denominator of the first term by x to the power minus m, so that both these m get cancelled out. Similarly, the numerator and denominator of the second term by x to the power minus n, and again repeating the process, the numerator and denominator of the third term by x to the power minus p. So now for the first term, if I multiply the numerator and denominator by x to the power minus m, I will get x to the power minus m in the numerator, then x to the power minus m multiplied by 1, that is x to the power minus m. Now in these terms the m will get cancelled out, so the remaining terms will be x to the power minus n plus x to the power minus p. Now similarly for second term, if I multiply the denominator and numerator by x to the power minus n, I will get x to the power minus n upon x to the power minus n plus x to the power minus m plus x to the power minus p. Plus now multiplying the numerator and denominator by x to the power minus p, the third term I will get x to the power minus p upon x to the power minus p plus x to the power minus n plus x to the power minus n. So now you can see that the denominators in all the three expressions have become same. Now I can directly add the numerators. So I will get x to the power minus m plus x to the power minus n plus x to the power minus p upon